Greetings, everyone. Welcome to this edition of our podcast with our webinar with thought leaders. It's a webinar. And today my name is Hyrum Anderson, CTO of Robust Intelligence, and I'm grateful to be joined by Daniel Kang, who is a professor at UIUC. Before Daniel was at UIUC, he was a postdoc at UC Berkeley in the Sky Lab, and also completed a PhD at Stanford. Daniel, welcome.
Thank you. It's great to be here.
Daniel, you've done a lot of work in LLM security, especially touching on many of the abuse cases. Before we get into the meat, can you tell us a little bit about how you came into this field of AI security and especially abuse cases?
Yeah, my story is a little bit roundabout. I guess that the long version starts back with my dad, who is actually a computer security researcher. But I was actually never that interested in understanding computer security because it felt like to me that it was very much a cat and mouse game. And so during my PhD, I decided to focus on AI plus X, where X was database systems and the data management techniques around AI. But since ChatGPT came out, and since I had a postdoc here at Berkeley, where I worked closely with Professor Jan Stojka, I had a chance to really explore different avenues. And I decided that with the new advances and the new capabilities, it would be really interesting to understand and go back to, I guess, my roots, if you can call it that, of computer security and how AI is going to change that. So that's where I really started to dive into it. And since I've started here at UIUC, I thought it'd be a lot of fun to continue this. And I've recruited several students to work with me on a variety of different projects, which I guess we'll get into today. But I'm interested in both the intersection. I'm interested in both how AI applies to cybersecurity and also how security applies to AI.
Wonderful. And we're back a little bit in cat and mouse today, aren't we, Daniel?
Yeah, absolutely. And I think that's one of the things that we're going to have to figure out. What are the right approaches to solving this problem? If you look at how standard computer security has evolved, we now have a lot of really good defenses for certain kinds of attacks. We have best practices around things like access control. And as far as I can tell, that is still very much being developed in the field of AI.
For sure. In terms of the NIST taxonomy that was published earlier in 2024, which inherits a lot of the threat modeling objectives from traditional security, where there's confidentiality, integrity, availability, and NIST calls it privacy, integrity, and availability violations. But with the advent of LLMs, a new category of objective was defined specifically for these AI security vulnerabilities, and that is abuse. So today we're going to talk about a few of the things that you've worked on, Daniel, and we can maybe use some of the published work that you've done as signposting for this. But I first want to just work with you and talk to you about some of the risks of generative AI that you've explored. And maybe for that, we can point our listeners to a paper you published, Identifying and Mitigating the Security Risks of Generative AI, which was published in late 2023. Daniel, tell me about some of the enumerated generative AI risks that you see it, and maybe later on in our chat, we can deep dive on one or two of those areas.
Absolutely. So when that paper was published, the focus was really around the chatbot setting. So essentially, when you have an LLM or different AI systems to assist people for different kinds of tasks, and these people are obviously malicious actors. So things like fraud, things like phishing, producing malware, essentially anything where a chatbot will assist a human in performing some malicious task. Now, I think that this is still should be or this is an active area of research, and there should be a lot of effort focused on that. But what I've actually begun to focus more on is the risks of AI agents. And here I'm specifically referring to an agent as something that can take actions through either the use of APIs or function calling. And this is particularly problematic in my view because these agents can be scaled out essentially to infinity by just paying extra. Whereas in the human case, there's obviously limits in terms of how much one person can do. And so, especially as agents and LLMs become more capable, that's what I'm really worried about. And so some of my own work showed that you can use AI agents to autonomously hack websites. And hopefully in the next week or two, we will have more work showing that they can also hack they can hack unpatched vulnerabilities in real world computer systems.
So the agent paradigm is interesting from a security standpoint on its own because of things that have been maybe glossed over in security fundamentals like trust boundaries, where an LLM, now the output from that LLM that is unsanitized can now book a calendar event or book a flight or send an email. That's its own thing. But I think now you're talking about agents that have been designed by an attacker to do something malicious. Is that right?
Yeah, I'm worried about both. I also have some work on the former that you mentioned. We have we put out a benchmark to study this. Yeah. So essentially the intersection of security and agents is something I've been thinking a lot about recently.
Fantastic. And for our listeners, I think one way to think about agents is it's like an LLM in a for loop, where in that for loop, there's a set of tools that can respond to outputs from as directed by the LLM, right? And the part, Daniel, I want to pull on, this can scale to infinity. That just means you can instrument as many agents as you'd like into this process. Is that right?
Absolutely. So for example, if you today, if you have, let's say, a penetration testing chatbot, a penetration testing GPT, and you want to use this to assist a human, the human has to go and click on, say, different parts of the website or different parts of the system and actually take the actions themselves. Whereas now you can, in fact, have the agent take the actions by itself without human supervision. And obviously, if you can scale this out, you can now all of a sudden attack or probe many websites at once, as opposed to having a person be the bottleneck in this for loop, essentially.
So Dan, for this, you published a paper in February that LLM agents can autonomously hack websites is the title for that. Can you tell us a little bit about this particular thing? What are the sorts of vulnerabilities that this autonomous agent can exploit automatically?
Yeah, that's a great question, because this question of capabilities is one that is being very actively researched in academia and other places as well. So what we found is that for many kinds of web vulnerabilities, so these range from simple SQL injections to more complicated ones, which involve multiple steps, like a webhook plus an cross-site scripting vulnerability, the LLM agent can essentially figure out what the vulnerability is by looking at the front-end code that is sent to the browser, and then determining that there might be a potential, the possibility of vulnerability, and then taking actions to then exploit it. So we have a list of 15 vulnerabilities that we tested in the paper that the preprint that we put out. And these, as I mentioned, range from simple SQL injections to more complicated ones like server-side request forgeries, and also things that involve both webhooks and, say, XSS attacks.
And what kinds of systems are at risk today? If you were to map this to a real world of you employing this agent to hack into a website, is this basically websites built with WordPress, Joomla, Drupal, or could this even map to more sophisticated enterprise websites?
Yeah, that's also a great question, because one of the things that's difficult in academic papers is to give a little bit more color around what the results actually mean, since a lot of it is speculative and doesn't necessarily belong in an academic paper. So for the work that we showed in that particular paper, I'm actually not really worried about it. We tested an open source vulnerability scanner, and so GPT, I think, can get something like 11 out of the 15 vulnerabilities. The open source vulnerability scanners can get something like 7 out of the 15 vulnerabilities. So if you're putting in best practices for security, it's actually not necessarily that big of a deal. Now, what is actually going to be more important is that we have some unpublished work that should hopefully come out in a week or two that shows that our GPT-4 agent, well, when modified, can actually exploit real-world systems for unpatched vulnerabilities. So essentially, if there's a CVE that's published, our GPT-4 agent, I think something like 13 out of 15 times for the vulnerabilities we collected on real-world systems, can actually go in and exploit that vulnerability, even if these vulnerabilities aren't that detailed. So this, I think, becomes a real worry, because the time from when a vulnerability is closed, when a vulnerability is patched, previously, someone had to go in and check, and like a malicious attacker would have to determine that this website has this particular version, and then it's vulnerable to this specific CVE. And that process is time consuming and quite frankly annoying. But now you can literally have an LLM agent just go around and then do this for you. It can literally just say, oh, new CVE, let me test all the websites that I think could potentially be vulnerable to this CVE. And this is where I think the scaling to infinity becomes really problematic. Unfortunately, I was hoping to have the work released before this conversation, but hopefully by the time this webinar is released, I should be able to send a link to you about the preprint.
Amazing. This just fires a bunch of neurons, Daniel. And I guess the thing that makes this really interesting is that number one, as you mentioned, this is now something that real websites, not just like a personal Joomla Drupal site that has always had lots of vulnerabilities, but this can be deployed against real websites. So that's a concern. A question for you. Is the nature of this agent, is it as simple as sort of automatically watching new entries be populated into the NVD, like the CVE database, and looking those plain text descriptions up in the CVSS severity scores, or is this manually instrumenting the agent to do that? How much of this, how much of the of exploiting a new vulnerability is automatic versus sort of encoded by the attacker into the agent?
It's almost entirely automatic.
Okay.
Yeah. So one of the things I think that people who haven't really worked with agents have a misconception of is that these agents are really complicated and they require a lot of instrumentation, and there's a lot that goes on. So we didn't implement the scanning of new vulnerabilities, since that we were trying to show capabilities. We're not trying to we're not trying to be black hat hackers over here. But the core agent itself is, I'm not exaggerating, it's literally 100 lines of code. That is all it takes to hack these websites. And our prompt is something like 1,000 tokens. So 1,000 tokens plus 100 lines of code means you can now hack real world systems. And I think this is one of the things that people who, as I mentioned, people who haven't really worked with agents don't quite understand the simplicity behind which these systems can be deployed. And I think that's what really worries me, not not necessarily the human uplift setting.
And to maybe walk back the fear a little bit, these are websites. This is not executing a breach in by getting initial access, exploiting command and control server in an enterprise. This is basically how do we find something that's already exposed to the world, already a vulnerability that we can exploit, that first layer. Is that correct, Daniel?
That's right. So if you were to think about how this would actually be deployed in a black hat setting, you'd probably have the agent find these exploits, report back what's vulnerable, and then have someone actually go do that kind of command and control procedure. These agents, or at least I hope, can't do the entire process by itself at the moment, but who knows with future capabilities.
Amazing. Last question on this particular topic. What are some of the defensive, I guess, strategies or maybe even defensive benefits to having this automated vulnerability discovery kind of capability?
So one of the things that we're working with right now is we're trying to get the technology that we developed in our lab into the hands of white hat organizations. And so one of the things that we want to enable is essentially, so today, if you want to do a penetration test, it's quite expensive. You need to hire a consultant, like a penetration testing agency, and then there's a lot of work that needs to go into making sure that all the parameters are set correctly and whatnot. With this technology, it would be really cool if you could do a penetration test every day, or essentially every time your system was updated in some form or another. And this way you can be a bit more proactive. And even if the penetration testing agent is not necessarily as good as a real person, if you can do it every time that the system changes, then maybe that'll actually help you be alerted to vulnerabilities faster than doing a full penetration test with say, an expert human in the loop. The other thing I'm potentially excited by, although I don't have strong evidence for this, is that the defenders typically have a lot more information about their own systems than the offensive side does. So one very simple thing is that they have access to their own source code. And hopefully, the defenders can build systems that can leverage both the source code and also taking actions on, say, a website or some other system to make the process of finding vulnerabilities much stronger on the defensive side than on the offensive side. That's something that I'm hoping to do research in the future as well, but currently don't have concrete results.
Amazing. Daniel, the last topic is related, and so much of what folks like you and we're doing at Robust Intelligence now is in exploring the boundaries of what's possible. And this can be a challenge because of, for example, terms of service for some of the tools that prohibit red team activity, we'll say. And in some countries, there are even more serious legal ramifications of that. I'm wanting you to talk through us. What are the challenges today as it relates to kind of doing red teaming and evaluations for AI, and what we can do to kind of make that a safe both for the providers, but also safe for the downstream consumers by having the community kind of poke holes at that. So first, what is kind of the state today?
Yeah, right now the state today is quite fragmented. Essentially, every service provider, every AI service provider has their own terms of service, and there aren't really best practices in place. And that's something that I hope will evolve over time. I think the work that you mentioned, we were advocating for legal and technical safe harbors for security researchers. I myself we've worked closely with OpenAI and Anthropic to understand their systems in a bit more depth. They've been very responsive to us, but of course, they have limited resources. And I think if there was a streamlined process to allow good faith security researchers to have these legal and technical safe harbors, it would really enable new kinds of research and understanding these systems. And actually, one of the things I want to bring up, which is perhaps not that well known, is that when GPT-4 was released, they had a model card or a system card associated with the model. And they, in fact, tested some of the things that we explored in our own work, including cyber vulnerabilities. And they essentially concluded that it's not that big of a deal. These systems aren't that capable. But what our work shows is that a GPT-4-based agent can actually hack real-world systems. And this is because of a lot of the scaffolding that we and others have built on top of the base agent. So in the academic research community, this is called elicitation, or there are many other terms for this, but I'll just use the word elicitation. I think that without these technical and legal safe harbors, despite what efforts that, say, the AI model providers like OpenAI or Anthropic or others might put in place before releasing these models, there's just many more researchers who are interested in understanding the end capabilities of these models. And it's just hard to imagine that they can have internally they can have complete coverage for testing. So this is one of the reasons that I'm advocating for these legal and technical safe harbors.
So the paper we're referencing is called A Safe Harbor for AI Evaluation Red Teaming, Daniel. And in it, you say, existing safe harbors protect security research, but not other good faith research. Can you help me understand the distinction between what I believe is like folks like you, Daniel, who are doing security research, and what other good faith research might actually mean?
Yeah, so there are other kinds of research that I would call not necessarily related to security. So, for example, understanding bias in models or understanding copyright, whether or not a model is representing copyrighted material, or understanding if these models can be used for non-security related illegal uses. So these are some other kinds of research activities that are I would consider in, well, depending on, I guess, depending on your viewpoint, in good faith, but not necessarily related to security.
That makes sense. Daniel, a fascinating conversation. As we're closing out today's chat, I first want to get your thoughts about where we're headed in this. You mentioned at the beginning, the security has been such a cat and mouse game, and it takes principles, like very fundamental principles, to get out of that. Can you comment on where you think we can be headed in AI security to get out of the cat and mouse game and get into more fundamental security principles?
Yeah, that's a great question, and unfortunately, I don't have all the answers, but I can try to provide a roadmap of where I think that these things should be going. So, one of the amazing things about standard computer security is that they've actually developed really strong defensive measures or proactive measures in certain circumstances. So, for example, access control. Even if a certain kind of server is, say, completely compromised, if you have certain access control procedures in place, it can only have limited damage. Other things like cryptographic primitives really allow for strong security in many circumstances. In my view, when it comes to deploying AI systems, a lot of what the security will actually entail is building around the AI, not necessarily the AI itself. So access control is a simple example of this. Perhaps you don't want the AI to have access to all of your private data, and there should be best practices and also computer systems put in place to ensure that access control around AI works both efficiently and also in a way that actually preserves, say, for example, privacy or security, and also prevents leakage. Also, things like if you're using agents, controlling what the agent ingests and also controlling what the agent can take actions, or controlling what actions the AI agent can take, I think is also another example of essentially something like an access control or a firewall equivalent for AI agents. I think these are the kinds of things that will really enable these AI systems to become widely deployed in the near term as the fundamental research in the AI themselves progresses.
Amazing. Daniel, thank you so much. As we're closing, I want to give you any platform you'd like to promote any of the work that we maybe haven't mentioned today, or give other signposts for where our listeners can find out more, Daniel.
Absolutely. So I have a Twitter account, and also which hopefully should be able to be posted online, and also Medium. So I mentioned some of the work that we unfortunately have not published at the moment, but we will hopefully be publishing in the next week or two. So we'll be posting both on Twitter and on Medium for any updates there. The other thing I'd like to say is that I love talking to early stage startups because a lot of the work I do is very academic, and I love to see how things are applied. I advise several startups myself. If you'd like to chat, please reach out. I'm happy to put my email and happy to provide my email as well.
Amazing, Daniel. Thank you so much for joining us today. As we've been talking about abuse, greater AI security, and safe harbor. Robust Intelligence is an AI security company. It's very interesting things we've talked about today. And we'll thank you for joining us today, Daniel. Thank you.
Thank you for having me. This was a lot of fun.